Yeah, there was a massive explosion of feces, and I've been covered in it just like a cartoon character. And I said, nope.
Alright then, we're doing something a little bit... What's my knee doing now? Put that away. We're doing something a little bit different here on XYZ. What I've done is taking our time in lockdown to have a couple of Zoom chats with some researchers to talk about why maths. Like, what the hell is the point of maths? Why do we study it? What have they done with it? Why? So, what we're starting off with is we're starting off by chatting to chemist 𝗦𝗧𝗘𝗩𝗜𝗘, who is professor at the University of Durham. We're going to talk a little bit about his research, which he compared to the 1966 film Fantastic Voyage. And we also talk about how he got into doing chemistry and about how he tries to nurture that inquisitive mindset. Now, it's a really, really good chat because Rob's an amazingly interesting guy. He actually is. I wouldn't choose someone who's boring for this. So let's get started with 𝗦𝗧𝗘𝗩𝗜𝗘.
What's the hat? My new hat's just arrived from the post. Thank you.
I've shaved my beard off. I look like a bit of a div, but it's not grown back.
And you're not missing the long hair?
A little bit, yeah.
Oh, look at
Very
me.
nice.
I won that fair and square on a competition.
Did you?
Yeah.
So the first time I met you was when you were a research fellow at the Royal Society. Are you still?
I am. I've got my extension, which means that now I'm year 6 out of an 8-year Royal Society fellowship, which means that your normal teaching part at university is somewhat reduced, and you teach what your forte and scientific interest and research relates to, and the rest of your time you're free to do your world-reading research. So I'm a sort of research professor at the Department of Chemistry at Durham University, which is good because we work on many interesting research areas, and all of them needs a lot of math.
Your research, Rob, how would you summarize that in not as best you can in like a minute or so?
Well, I'm a chemist. I started my life as an organic chemist, sort of making interesting molecules, and then I realized that it's not necessarily what I really enjoy. And then I slowly moved towards the fact of making things and making instrumentations to help chemists. And one of the biggest sort of part of our research is to study how light interacts with certain molecules. And that might sound very sort of simple, but the way molecules interact with light allows you to tell a lot about that given molecule, whether your chemical reaction worked, what might that molecule be able to do when it comes to sort of synthesizing new drugs and interesting compounds. For example, the holy grail at the moment is finding the vaccine for coronavirus, and a lot of scientists using light to probe and test their molecules, that whether it is supposed to do what it's supposed to do. And then we build microscopes, and that led from the fact that we initially made probes which allow you to visualize certain parts of the cells and study chemical reactions inside the cell using light. And then you're pushing the boundaries, which means you're using maths, and you always complexly calculate of what's the smallest possible thing that your current contraption will allow you to see, and one builds on another and vice versa, in terms of you pushing the boundaries and building better systems, but the more parts you add into it, the more complex it gets, so the less light it goes through. So it's a big balancing act. And then 5 years ago, I've had the privilege to listen to one of my fellow scientists talk from the United States, and we struck a collaboration for light-activated nanomachines, which are clever little molecules that when you shine light at them, they do something. And in this case, they spin very fast. And the idea was that can this molecule drill so fast that it will just drill through a cell membrane and kill it from inside. And that again sounds very simple, but if you think about it, if this molecule can only exclusively be bound to a certain type of cancer cell, and then you simply use a very friendly light source to shine it on a person, and we are transparent in certain wavelength of the light spectrum, everywhere it goes through. But then where the molecules bind they get activated, they drill across, they kill the cells, and in this case, because they were only bound to the cancer cells, they only kill the bad guys. So very simple, isn't it? It sounds very simple, but it's very complex. It comes to complex chemistry, comes to complex light interactions, and obviously complex instrumentation, and all of these things everywhere needs maths.
Did you ever imagine when you were a kid at school, like 10 years old, this is what you'd be doing?
No. This is the beauty about being a scientist, that you have an idea and you meet people and you do something and you become specialized in one area of chemistry, in this case physical chemistry, and one area of that which is microscopy, which is an interdisciplinary subject. And even 5 or 6 years ago, I never even thought, when I was in the lab making things, that one day I will build microscopes which are going to be unique, and then I will meet a guy, and then I will work on this. And then there was a film in I wanted to say 86, I might be wrong on the date, which is called The Fantastic Voyage, when one scientist got ill, and the other scientist's idea was, I'll jump into a little submarine, I got shrank myself, I get injected to the bloodstream of my friend, kill off the bad guys and come out and everybody will be happy. And it's really ironic that we're pretty much doing the same thing, but using clever chemistry and clever physics in terms of light activation to make a little mini submarine which will get to the bad guys, and when you shine light at it, it's like solar powered, it will drill across it and eradicate it, leaves everything else intact, and then it just clears out, and voila, you basically managed to find another way, or a good way of treating certain type of cancers with clever chemistry and clever light activation. And yes, I never thought of that. As a scientist, I don't think you can dream about, I'm going to do great things and then I'm going to use all my skills. But eventually, it's the opportunity when it comes around, and you look back at it a couple of years' time and you go, I've never thought I'm going to do this.
Yeah.
I think it's the scientific curiosity. The best part of science is when you go and when you have the time. And in this case, link it back to the Royal Society's fellowship. It gives you time to do these things. When you go, I wonder if I try that, will it work? And can I do that? Oh yeah, I've got A and B. If I connect it together, can I get to C? And I think that's the kick of what you get out of things as a scientist.
Was there something else that you wanted to be when you were a kid?
The very important thing, I think, at school is that, we all dream up, and when we grow up and as we get older, our sort of expectation of becoming a space cowboy and an astronaut and a bin man or a lorry driver, it always changes. But when you're at school and we have a really good teacher who not only educate you but sort of entertain as well, doing it in a way that you really fall in love with that subject. And then unfortunately it can lead to the fact that other subjects are a bit neglected. Because you go with history, it's like, why do I need to memorize all these dates? Well, once if you get to Who Wants to Be a Millionaire, and there's a question about dates, you will realize that, I wish I would have listened a bit more. My chemistry teacher at primary school was like really, really great. And then I went to competitions and I started to enjoy it, and I really liked it, and I spent a lot of time on it. And then I thought, I'll become a chemist. At one point, I wanted to become a veterinary surgeon, but I did an intern as being a vet, and I had to treat a horse with colic, and there was a massive explosion of feces, and I've been covered in it just like a cartoon character. And I said, nope, I don't want to be a vet ever again. No, never, ever. It wasn't very good. So
how old were you?
I think I was about 14. They did tell me what to do, to give basically a horse an enema. And then they put the funnel, put things in, and then things went much quicker than they anticipated, and I didn't have time to run. And the horse is a big animal. There was a lot of poo everywhere, most of it on me. In the fact that my dad basically didn't want it to put me in the car when he wanted to drive me home, we went to opposite the street to the car wash, and he hosed me down with a power wash. It was a funny story.
It sounds like you were quite involved as a kid then. Were you quite a smart child?
I don't think I was smarter than the average kid. It's just I've been interested in things, and it's probably my nature that I really like to pursue things. And then it's just like my dad, like when it came to DIY, he made it sound very interesting, and you get involved in it, and then you go, oh, it's really good. And then I think I was like 10 or 11, and it was Mother's Day, and I thought, well, rather than going out and buying a flower, I wonder if I can. My dad was a carpenter. I wonder if I can make something lovely out of wood, and I did. But then I also ended up in A&E. I needed a few stitches because things are sharp, and then you might not pay full attention when your dad explained that. Yeah, you need to be very careful with that. But that it is great, and you learn from it, and and you just like, oh, yeah, this worked out. So after that, I've just always made DIY presents to everyone. And the same came with school. And then I realized that, oh yeah, if I go to this chemistry thing, it helps out and it goes well. And eventually, the way things worked, I didn't even have to have an entrance exam for the university. I've been offered a place based on how you scored in high school in a chemistry competition. And that was like, wow, it's really good. And it took the stress out of applications. And the same thing was at university. There's so many new things I could be engaged in at university. You're first away from home and loads of things, but then realized that, yeah, if I do quite well on the course material and be top of the class, it turned out you even get a scholarship. And that paid for rent, and you didn't have to ask your parents for rent. And so it worked out. So there's a lot of luck involved in many things. But all comes down to the fact that I had a very good teacher at chemistry, and he made me sort of fall in love with the subject. And then you're interested, and it kind of worked out for the rest of my life.
It sounds like you have a very inquisitive mind there. Like even at a young age, that must.
Yeah, it does help, and it does comes with its burden as well. Because when you get much older later in life, and you get some funding for some very expensive instrument to use in your lab, and the first thing you do is, like a naughty kid, you take it all apart to understand how it works, and then you have to be very, very careful to put it back so the warranty is not voided. It lands you into trouble. But yeah, I've always been interested in how things work, and if I do this, what it will cause and how it will sort of pan out. So yeah, I really liked it. Yeah, it's just still up to this day. It's just when you try to sort of new things, or when you have your hobbies and you pursue it and get sort of full dedication to it. I think it's probably the best to sum it up as my granddad always says, like, son, you do things properly or you don't do it at all. Wow, so it's
what did granddad?
Sorry.
What did granddad do? What was
Granddad was an interesting figure, because granddad was fought in the Second World War, and he was a war veteran, and he had lots of health issues and lots of sort of amputations and things like that. And being in a wheelchair with both legs amputated knee above, and all of the top digits and all of his fingers missing because of arthritis, he was still a carpenter and knocking out furniture, and the queue was out of the door for people wanting what he was doing and coming even for advices or apprenticeship. And it was just phenomenal, and that sort of sums it up and taught me a lot, saying, like, where there's a will, there's a way, I think.
Yeah. So what did mum do? What I'm getting
my mom and dad, I mean, I'm the first one in my whole family who ever went to university. It's mainly for the fact that where we came from, and in Hungary back in the day, it was the sort of most people who were coming from working class families, they were hitting the job market quick and trying to get on the ladder, buy a house, get an independent life, things like that. And my parents were the first one who sacrificed a lot for me to not to get to university, but to get to that state mentally, in terms of like want to be and want to go to university.
Yeah.
And student loans at that point were not invented, so everybody had to rely on their parents. And yeah, it was a lot of sacrifice, so we didn't go on holidays or things like that.
I was the first one in my family to go to uni, but I was blessed by student loans. Just took a massive student loan, and it's still sat there, just picking up. I don't regret it. You went and did chemistry though, yeah?
Yes.
But Debrecen.
Chemistry degree in Hungary, that was 5 years. So
5?
Yeah. So you've got 4 year, which is your studies. The first 3 years the same for everyone. In the 4th year, you kind of specialize in an area of chemistry, what interests you. And your whole 5th year is dedicated to a research project exclusively, a whole year. And then that's how I ended up working with the chemistry I did at that point. And then my supervisor knew my PhD supervisor. I always wanted to go abroad to study a language, and I spent my 3rd year in Italy as an exchange student. So it kind of taught me that, yeah, I want to go abroad because there were sort of bigger opportunities there. And then I ended up in Durham, did my PhD there, and then sort of built up towards independence, and I'm there ever since.
That's cool. So I remember the first thing I ever noticed about you when I met you, I was like, he's Hungarian, but he sounds like a Geordie.
Yeah, you did pick it up. Yeah. Blending in. Yeah.
How's your lad doing then? Because I think you once told me that you've got a kid, like he was 8 when I think we last spoke.
He's 10 now, yeah.
Yeah.
He's 10, he's at school, he's finding homeschooling very challenging, and I found homeschooling occasionally challenging because you've got questions like, Dad, do snakes have long necks or long tails? And you go, the whole thing is just a neck-tail thing, so yeah. Then you go out as a sort of outdoorsy person and you find a grass snake, you bring it home. You, as a chemist, a spectroscopist, you put it under a very big lamp, so you're trying to see that it's just a big spinal cord and nothing else. And then you find that, yeah, it has little tiny bone fragments, which are leg and tail. And yes, it probably would have been much easier if I would have Googled. Then you put the grass snake in a box, saying that next morning you go back to the wild and release it where you found it, only to find out in the morning that the box is empty and the snake is probably somewhere still in your house. So, yeah, that did not work out.
It'll turn up somewhere.
Yeah, that's what I'm afraid of.
I have a pet snake and it went missing for 4 days recently.
Uh-oh.
And it turned up on my bookshelf. It was like reading all my science books.
That's good. That's a very well-educated snake, that.
It is, yeah. Do you think your lad might go into science or something?
I try not to influence things because I find my sort of path without my parents like pushing it. Yes, he probably has the advantage that when it comes something scientific, I've got a passion for it, so I'll try to teach him and get him interested in it. And it's the same thing. We're very outdoorsy. We fish, we hunt, we do loads of things, and out of all of these things, he suddenly a year ago got very interested in birds, and that's what his interest is. So I'll try to support it with books and various things, and hopefully he'll get a passion for it. But again, a lot will depend on how in school he will be made sort of to fall in love with a certain subject.
Yeah, well, like you say, it's not about what you want them to do, it's about what they want to do, and just supporting. It's just, to me, it seems like a lot of your mindset for science is like amazingly like, well, you know, like you saw, what's the word for it? I can't even think.
I don't know. I mean, I do like to be inquisitive, and
inquisitive. That's the one. Yeah, and
also do like the fact that it really annoys me when I don't understand something.
Yeah.
It really frustrates me when I say, "Oh, I don't know the answer for that. Oh, I have to look it up. Oh, I have to look it up and absolutely look it up well that I have a good informed answer for it." And having a son in this case is helpful because some of the things, I mean, maths is one of the things. I mean, when I thought I've been taught maths differently. So when it, for example, came to like division and there's the bust-up method, that was new to me. I had to learn it, and I went, "Oh yeah, I did learn it differently, but yeah, it's good." And now, like, you go there, so I explain it to you. So homeschooling at the moment does throw up a few challenges for sure.
So why is it?
Sorry.
Why is it that you don't like to look stuff up if you don't know something?
No, I like to look it up, but it just frustrates me if I have a gap somewhere in the knowledge.
Yeah.
And I think that's what the scientific hunger or quest for knowledge is about. Is that, oh my God, I don't know that, I must know the answer. And I think it's Toby actually who asked my son, is that like, "Oh, Dad, why do I need to do this maths?" And I said, basically, level 1 is to asking your family how many eggs everybody wants, and then you add them together and make an omelette for the family. Level 10 is to calculate out how on earth you'd be able to use gravity to keep the International Space Station orbiting well in around the planet and not falling and plummeting into the ocean. So yeah, that's that's the stages of our thing, and it's everything can be simplified down, and it makes a need for it. But yeah, I mean I think that's one of the reasons why I like math. It's a universal language, isn't it? If I show an equation to any of my colleagues, even if we don't speak the same language, they will understand it. That's good about it.
I like that.
Yeah, it's good.
So I'm aware of the time and I should probably be letting you go, but if someone was, like, say a student said to you, like, why am I learning maths? Say like a 16-year-old, where am I going to use it?
Everywhere. It's as I said, it's a universal language, and you use it everywhere, even unintentionally, even when you don't realize it. You always come back down to the fact that most of the things will be simplified by an equation or by a calculation, and we make millions and millions of calculations every single day without even realizing it. And the more complex a thing gets, the more complex calculations you need to use. But math is there. As a chemist, we rely on maths. As I said, just the thing that we study how a molecule interacts with light, to interpret these results, you need equations and you need to deduce and decipher the information out of all the complex numbers. And yeah, I'll always encourage everyone to have maths, because remember, if you know how to calculate things out, it's very easy to whip out our mobile phones and use the calculator on there, but there will be a time in life when there will not going to be a mobile phone in your pocket and you go, oh, yeah, I'm stuck. So I think that's why you need to. And everything, most of the things in nature, laws of physics, everything is underpinned and being verified and being interpreted by an equation. And if you know maths and you can understand an equation, then you understand how things work.
Do you think maths might become obsolete? Like, it might become a classical subject replaced by computer science?
No, because eventually you cannot replace the human. There's always going to be a man in the machine. If the computer goes wrong, you need somebody who understands the math and how did it work to fix it. And if you can be that person, then eventually you're not relying on that computer. You can do most of the things yourself. And that could be life-saving in many aspects of life.
Definitely. I'm pleased that you've said this as your response to that, because I
Great. Good.
Right, nice one, Rob. I should really let you go because you said...
Thanks a lot, and best of luck. Keep in touch.
Cheers, Rob.
Bye. Bye-bye.
Alright then, big thanks to Rob Pal for taking part in that. I personally really enjoyed that. He said he did as well, and I just really like the kind of insight of how people get into jobs, like what these jobs even are. And this is Rob's was a chemistry one, and it's just really nice to hear about how he had that journey of getting into it, and then about how his attitude to maths is. So big respect for Rob for taking part in that, and I hope you enjoyed it. Next time we're going to be talking to Emma Osborne, who is an astrophysicist at the University of Bath. But she does more of the science communication role, so it's a little bit different to Rob. Okay, see you next time.